Hey, welcome back to this Global Hack Week. I am so sorry. I have to admit it was completely my fault. This starting late. I was waiting for the previous session to end, and I lost track of the time. And I was like, okay, I was needing to wait more, um, and I was just simply staring at the screen, and I realized I haven't started the session. So we were supposed to be live like 5 minutes ago, um, even more, even 10 for you to pass the ad wall. So I'm so sorry if you didn't pass the ad wall, or well, if you didn't pass the ad wall, you're probably not watching this, but you got me, right? So let's not waste more time and let's get started with the second part of this real world IoT project part two. I think it's a great chance also for the rest who haven't joined yet. Let me move my screen here. For the rest who haven't joined yet and didn't watch the part one, to make a recap, right? So let me know here in the comments first if you watched the part one or you just are jumping into the part two and waiting for the best. Um, and before I forgot, let me share the checking link because I always forget this. Oh, my keyboard wasn't on. Sorry. Give me a second again. And I need to introduce myself as well because I also always forgot to do that. Here's the link, and my name is Alberto, your mainly hacking coach from Mexico. So let's keep started with this. In the part one, we discuss what we are doing now, like the project. I mean, um, this project actually is my thesis project. I defend my thesis last Monday, so I wanted to share, and I was planning to share this, of course, before even the global hack week planning. But I wanted to share the results. And in the previous session, we get like in theory and yeah, very theoretical explanation of what the project do in very short words. And if you want to explain it more, please watch the recording of part one. This is a project that wants to automate the acoustic treatment of an studio, right? How we do that? Moving acoustic panels that has three phases: one reflective, one that has absorption, and one that um, diffracts or give more channels of reflection for the audio, right? And we take a look to how the structure of the project was. It is immense structure of 9 panels that it's the long of one, um, how to say that, with it's almost the length of the wall. I will say it's even bigger than a bed. It depends the size of your bed. Yeah, it's even bigger than a king bed. But yeah, it's almost the size of the wall. And in thickness, I think it's around 30 centimeters. But yeah, you saw the drawings and the schematics. It was huge. And in the muscle of that, there are 9 motors that are connected to 5 Node MCU boards. And I have one Node MCU board here. Actually, it's not one of the project, but one that we had in case one of the others burned. So I told you and I mentioned that do the dimensions of the actual project, I could not share the real um, prototype working because there's not even here in my home. It's in our place, the studio. Um, but I have a small part of it here. So we are going to try to replicate the things that we worked on during that, and so you can see how it works in one of the things that you can be more interested. That it's the software part, right? Because the mechanics part, it's a lot of work that it will be interesting to discuss. The acoustics, and we mentioned this in the previous one, in the previous session, required a lot of processing, a lot of mathematics, a lot of um, decompilation integrals, pure acoustics treatments, right? But the one we could care a lot, and the one you can relate and try to replicate yourselves, it's how we connect the devices, in this case the node MCUs, which uses an expressive chip to connect to internet via the MQTT protocol. um, and you can do that, and parts from the code, from the base code that's shared, uh, and replicate in other scenarios of IoT. I don't know. I put the example of an agriculture. If you want to grow tomatoes, how you can measure humidity, how you can measure a lot of things, the solar intensity that get to the plant. I don't know, things like that, and then process it and do a lot of things with that, um, just to get an output of, I don't know, a prediction of how many tomatoes you'll harvest the next season. That could be an interesting project. Um, so let's get to the code. Mhm. And for this, here I had the screen. Just let me start sharing it. And if you want it to be bigger, just let me know. We were taking a look to this. The Yeah, I think you can see it now, right? This is the audio service, and the audio service triggers a lot of MQTT service things, and the MQTT service makes use of the MQTT utility file, and this utility file, it's separated logic because this, it's agnostic of anything you want to do with it. So what I mean with that is that you can completely copy paste this file into your projects and start implementing MQTT. But hey, last session we didn't get a chance to actually talk about this protocol, so let's try to talk about it more right now. And for that, I have this page that it's emqx.com. uh, I use this broker, not for any other reason, but because they had a image in Docker that was ready to use. But there are many. I mean, you can use Mosquito. I think it was another one that it was like Hive MQTT or something like that. Uh, but for the moment, this is the one we are going to focus on. And this also has implementation with cloud. So I even tried not only the free tier, but I tried the paid one. I have to say it's a little expensive. So I would love to see some more student credits or something like that, to test it more, because for the thing I paid, that's why I decided to shut it down and run it locally at the end. Uh, but yeah, I mean, it's worth it. It's worth it if you're. if I'm not talking with students, if I'm not talking with enthusiasts or people who wants to learn, but to take it to a productive environment, it's completely worth it. I will say that. Uh, and as you see, the unified MQTT and AI platform from real-time intelligence, software-defined vehicles, smart manufacturing, a lot of things, right? So the product, it's the NQX, it's the platform, but NQ, it's the broker. So it's kind of hard to explain. Let's try to get Google on this because I didn't understand that the difference neither. But for what I get, it's that one thing it's the product, and the other thing it's like the platform around that. Right? One it's kind of open source, you can use it, and there's no problem with that. But hey, we also provide like the infrastructure for that, right? Of course, it's like similar to Arduino. If it sounds familiar to you, Arduino are Library boards. So there's open hardware that you can uh, take all the files and manufacture yourselves. But they say like, hey, we save you the trouble for doing that. If you want to buy one of these boards from us, it's okay. If you want to take the files and go and manufacture them yourself, that's fine too. So EMQ without DX. Um, we need to specify, of course. Huh. So this is the page for that. So let's start reading. The MQX, it's the world's most capable, reliable MQTT platform designed for high performance, reliable, and secure IoT data infrastructure. It supports many versions of the MQTT protocol, as well as other protocols like modifications of it. Um, Enables to connect to million IoT devices, process routes, blah blah blah, key features, uh, 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 comprehensive protocol support, over quick full MQTT support, massive and scalable at the palm of your hands. The data hub, I think, yeah. So this is the one I use. That's the simple way to get this running and up and running, which is the setup in Docker. They also have dedicated servers, serverless, and Bayok, which I don't know what it is, but hey, I run it locally. So let's open Docker. You can do it from your terminal. Don't worry, but I want it to be very interactive, so I'll open Docker Hub. Let's go to the dashboard and let me make this bigger. Okay, perfect. I think you can see it now. So I have the MQX image running here. There's a lot of things that happened, but basically what we are doing is that we want to run the image of MQX in our ports, and these ports serves different reasons. Some of them, like this, it's for using the TLC protocol. Some others are for the secure protocol from WebSockets and from other things. And this last one, it's one thing I found like the greatest of this specific broker of MQX, sorry, of MQTT, which is a built-in dashboard for managing all connections. So if I run this image again, and I visit this port, you will see localhost, and the number was 18. We will see the dashboard. How you log in the first time you're running this out of nowhere? Don't worry, the user it's always admin, and the password it's public. Then you will receive like, hey, you should change the password. You can skip it, no worries, or you can actually change the password. This it's going to be the dashboard for all your IoT, right? Which I found great because you have this very quick in the palm of your hand. So the uptime right now it has been little than a minute because we just opened this. We have an open source version running of this. We can manage how many nodes we have and the memory and a lot of other things like all the connections, the subscriptions, the retained message, some topics, and we will see the charts for that as well. We can add authentication. We mentioned, for example, that in our previous implementation of the server, the interface, and everything. We weren't using that, but let's start making some connections here. Let's start connecting via MQTT to the broker. First, and the first we are going to connect, it's the server, right? So we already checked on the server that we have the MQTT utility. The app utilizes the setup client. Setup client is inside the services, and services for the setup client. The only thing that does no, this is the audio one. Let me close it. Setup client. The only thing that does it's that it passes the topics that gets from the constants. It initializes passing the callback, and the callback just manage the messages. And for managing the messages, we define a structure to get the category, the subcategory, the device ID, the mother ID, and a lot of things. How we can manage that? Well, from the process messages, we receive the parts of the topic. The topic, it's the full char set of the subscription, and we define that in where. Let me open where I okay here. We define that here. There's a map of that that it's fully my decision. There are standards and good practices about this, but hey, I decided that I wanted to do motors, the device, the topic, the ID, and the subtopic, right? So that's how I know this is going to work. So we initialize and we use init mqtt, which is a function that we require from the utils. That's what I mentioned. This is completely agnostic of the implementation. I am doing an implementation here, so you can completely take this file and implement it in yours, right? Um, the init client, it connects, passing the broker URL. But what's the broker URL? Well, great question. Broker URL comes from the config file, and the config file here, it's just a model that requires the um, environmentals, right? So let's check the environmentals. Right now, my broker URL, well, this was when I was using the deployment. For the presentation, we used the deployment, but again, I shut it down as the moment we finished the presentation. And since this wasn't going to be a project that was going to have constant use in real time and blah blah blah, it was just for the presentation. I shut it down because it was it was costly. Let's say that. Right now, I'm going to open an MQTT. This is very similar, right, to what you could know as HTTP. Well, this MQTT double dot slash slash, and the this is the IP. How we get the IP? You can open your terminal and type epicconfig get id if address and in the direction 0, right? So this is mine. And I can close this. And the port we're using, since we're using MQTT without the secure one, it's 1883. Take a look to this, for example, where we were using the secure one and the port was different. Also, it depends on the configuration. This is, I do not know if it is fully customizable, but you can change it. Um, you can change it. But the recommendation is to use these ports, right? I have a username, a password, and a client ID. Again, right now I'm not using these two. I was using them for the secure connection because it's a requirement, but for the local one, I'm not using these two. Also, we have the Mongo connection and the port where we are running this. So the moment we node server, we run this, we will see Mongo is connected, the server is running in this port, and we also make the connection to the broker. How we can verify that? Well, we can open this and see the logs and say like, hey, we set up the TCP default. Well, no, here we don't have any log for that. But hey, don't worry. The other thing we can do is go to the dashboard. That's the reason why it is there. And we can see the connections. So we have the client ID, Node.js server, as the one we define here, Node.js server. The username for this, which is server, the connection status, the IP address where each comes from, and some other things that keep alive, clean start, section experience interval, and connected at what time, right? Let's connect now the interface. So let's open the interface and let's see how this connects. This is an interface. I think we didn't explore this that much during the previous session. We just explored the treatment pages, but this page, this UI, it's on Next, right? So this is a Next app um, that I deployed on Firebase. That's why you are going to see this page or this Firebase file here. And for the connection, same. We have to set up some environments, the password, the username. Again, we are not using these anymore because previously this was connected using WebSocket, web secure sockets actually. Right now it's connected just via WebSockets to the local host and the port, right? This port is different as the previous because we are not connecting via MQTT. And well, it's kind of confusing. I know we're using MQTT protocol, but we are connecting through WebSockets. So that's why we're using WebSocket, the local host, and the port. Right, the port is different. Um, since we're running the server on the same local host and another port slash API, this is going to be the base URL for that. The client now it's Next.js app client, and you will see that we are going to make the connection on the landing page. So for this, we use, oh no, um, oh no, yeah, this is one. Uh, 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 Tracks, land success. Uh, Wait a second, I think. Oh, well, I have a question. Let me. Do you think some of the courses on YouTube with a focus on VS Code worth taking? If so, any recommendations? I'm new and finding the tools feels really interesting. Um, mhm. But I don't know. What you mean with a course that focus on VS Code? Um, I think of many things when I heard that because I could say like, okay, you can give a course about how to debug on VS Code, like the internal tools. Yes, VS Code is widely used for many developed environments. Learning to use VS Code will be worth your time. I do agree, but I don't know. I want to be very specific with these questions because it happened to me in many events that some of the hackers asked me about, like, for example, with Google Collabs, they say like, oh, I don't know how to move from the Collab to a real world environment, and I'm like, okay, the thing with Collab is that you have everything and you don't need to worry about anything, right? Um, the thing with VS Code could be the same. You could write code directly on a plain text editor, like the Node block, and you can run that. Doesn't matter if it's not uh, Visual Studio, right? Um, the thing about learning these tools, it's something tricky for the beginners because they tend to confuse the use of the tools. They tend sometimes to believe the tool, or for example the environment, like Visual Studio, Copilot, the collabs, Jupyter notebooks, even JetBrains IDEs. I don't know. Some of these they tend to confuse them with the actual things running the code, and that is not the case. The If the question it's more like the one Amari says. Or the one I was mentioning before, like it's useful to know, for example, the command palette, and that you can shift command P and type things here that can make your flow, for example, faster. And you can see that, for example, with Beam. You need to learn do Beam. That's the joke. You cannot just close it with the X here. You need to learn commands. You need to learn shortcuts. You need to learn a lot of things. So it's worth learning your tool. Yes, the question, sorry, yeah, the answer will be yes, but just don't confuse it. For example, some courses may have a little that follow full course on VS Code, teaching you its fundamental features and the individual work style. Yeah, yeah. If that's the case and that's the focus, I would say yes. It's worth knowing that for the same reason Amari mentioned. It's worth your time knowing grade your tools, same as the programming languages. And I was always mention this, for example, a course in Python, it is not a course about how to say or how to perform algorithms. It's not a course on how to perform um, I don't know, any other things, signal processings, for example. It's not a mathematical course. It's just a tool for doing those things, right? You can do it with Python. You can do it with R. You can do it with JavaScript. You can do it with many tools, and you use sometimes many tools, right? For example, if you're building a chair, you probably not just only a hammer. You need a saw, and in combination, you need I don't know. Chainsaw, motor saw, electric hammer, things like that. You're getting the idea. Alberto, I'm having trouble getting past the sign in screen. Do I need to modify the config file with the Docker container that's running? Um, no, but make sure that you're selecting admin as the user and public as the password. I don't know which values you're adding. Um, and well, also, that could be another thing. Yes, make sure that the image you're running, sorry, it's the same as this one. Um, mm, 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 this one, Docker run minus d of detach minus minus name the image name nqx and deport. And well, that will be a great question. Docker run minus detach without. Oh, okay, yes, yes. Um, this is web UI. That host. Yeah, this EMQX, it's the one I added. So this is the common. So make sure that this one's the actual that you run. Yeah, that's the one I'm running. The default admin password, it's that the in the README. No, I don't have any on the README. Oh, I get the confusion. Okay. Um, you mean the README of my project or this README? Yeah. Sir, sorry, I was. Yeah, you're right. I didn't pull the enterprise one. I just pulled the EMQX without the enterprise. Yeah, yeah. That's it. Yeah, sorry. I thought that was directly this. So probably that's why it's not working. So yes, we have to be careful with that. And hey, you're following it. Thank you. So let's continue. Um, sorry, I was shocked. To summarize, just take the Visual Studio Code to course to know your tools, and let's connect this to to the broker. Uh, I kind of forgot where I made the connection here. So I think, yeah, I also had an utility that's MQ topic. Uh, and I also have the audio service, but I should have more. Manual control, treatment, these are the pages. No, control graphics, context. Yeah, I added the context. So where I use the context, that's a great question. Create the context. Yeah, I thought it was on the landing page, but I don't see that. Okay, tuning context. Create the context here. Publish options, context type. That's in our interface. Create a context. Okay, let's see where is the context used. Like the layout. Oh, of course, it's in the layout. Um, yeah, it makes sense. So once this start, we use the MQTT provider context, and we wrap everything with that. Uh, and the context files, what it does, it's that it has a MQTT library from MQTT, same as that. So this MQTT library contains the instructions, but let's start taking it step by step, maybe making it a little bigger for you. If you think that's not big enough, just let me know, and I can hide this. So we define the connection status. It could be connected or connecting or disconnected or even error. We define the publish options. which basically are two. We mentioned these, the QoS, quality of service, what I understand, and we mentioned the part one that we use three principle: zero for just like fire and hide, like we send the message, we don't care who receive it, uh, an intermediate, or we do care a lot, and let's make sure that the subscriber receives the message. And it can be the opposite. We can subscribe with one of these QoS, right? The retain, it's, for example, if we want to set a flag, and I use retain in many of the messages, that keeps the history every time in the broker. So let's say we have a connection of a device, right? A single device like this board. And we have the server sending a message. If the server sends the message before the device subscribes, we cannot see the value of that. But if we retain it, we can see every time the value of that, or at least the latest. So the context type also can get us the communication status, the message, and the message we're going to publish. We create context with default values that's disconnected because at first we need to connect. We don't have messages and we don't have any message to publish. So for creating the MQTT provider, we use the hook of useEffect in React, and we get the broker URL. If there's no broker, well, we throw an error, and we use the library to connect via that broker URL, but also with the client ID. Remember, for having the name Next.js app client, blah, blah, blah. Right now, we're not using the username and password. It does not require it, but it also doesn't harm to add it. It will not throw us an error, even if we have or not have it. Um, how are you accessing this MQTT React project? It's this part of the Docker image that we pulled? No, this is mine implementation. So the code for this, it's here. Well, not in the server one, but in the repositories. In the repositories, you will find the interface, the server, and the device one. So here's the link for that. Oh, I think it wasn't copied. Okay, here's the link for that. No, looks like this is your own separate project. Is that correct? Yes, it is. Here's the link. So let's continue. When we connect, now we have the ability that we created a client, and the client has methods similar to the server, right? If you take a comparison here in the MQTT, oh my god, give me a second, utility MQTT, it's the same. We have an on connect and on messages, right? So let's move back. And on connection, we want to subscribe to these topics that are from the constants, the device status and the working status. And we also want the message on, right? Every time we receive a message, we add this to the set message context. And finally, we return this as the client to be accessible in every time of the application. We have our utility functions as for to publish the messages, and we return everything with the context provider. So let's not focus on the how React uses context and the providers and the hooks for this, because I think it's not the purpose or the intention of the session, but the idea of using MQTT, it's the main topic here. So again, we set a list of topics that we are going to subscribe to, and we add a publishing uh, functionality for publishing in many topics, right? The topics description, we set it here on the server. It's accessible and it's documented. We need to have this in Congress in all the parts of the application. And since we're using this increase in these three pieces of software of our authority, um, the devices, the interface, and the server, uh, well, that's simple, right? The only piece of software that we didn't build, but we are taking advantage of the existing implementation, it's the broker, which is the one we were checking, Amari 27, which is this one. We have the image on Docker, right? So let's continue and explain it that the only thing missing will be running the project the next project, right? So let's open that. Oh, yes, it's open. We will see at the moment that there is not a new connection yet because this wasn't loaded. So the status here it's disconnected. It blipped because it was really fast, but it moved from disconnected to connecting to connected. And now if we come back here and refresh, we have the Next.js app client, right? We have these two connections now. Great, great, great. Now, what else? Well, we discuss and we talk of what this is and how we do it, but for the moment, let's go to the manual control. And here we have all devices unavailable. Let's move to explain um, what the code for this device is and how we can modify it. And well, we already covered the interface. We covered the server. We're missing the devices, the most exciting part of an IoT project, right? Um, what does the TT stand for? That's in Spanish, trabajo terminal, or um, how to say it, like your end project. I don't know, work terminal. Yeah, um, not as work as are your project to finish, right, or something like that. It's a different translation, more like um, the last. Yes, yeah, exactly. Yeah, like your final project. Yes. uh, yeah, I was mentioning this was like my thesis project, so that's the meaning of the TT or what it stands for. Um, so EMQX is the data broker which provides a stream of data to the interface. Let me open the slides for that that I used during the presentation. It's something like this. So it is not like that fully just for the interface. Actually, the broker connects to all the parts of the MQTT communication. It's the responsible of managing the message sending and receiving it. So you can think of it as the mailman. So the mailman um, receives the messages, but also it's the one in charge of delivering it to the subscribers, right? Um, that's what EMQX is. So let's move here. We can close this. We can close also this one. And okay, let's start with the boards. Let me open and let me make it bigger. So what we have here, it's a a project that okay that use okay, so EMQX is the primary facilitator of moving data between the edge devices, the interface, and the server exchange information with the database. Yeah, so they basically let's return uh, to that diagram. Um, the interface, actually, this row, it's kind of yeah, it's bidirectional because we subscribe to the working status, the device status, but also there's another direct communication from the interface to the boards that it's as top. I added that stop here interface and not in the server like the rest of the functionalities just for speedness, and that's the only reason. Else, the interface communicates with the server via REST API, the all live HTTP protocols, and we receive it as routes. We declare our routes, models, and everything. We talk a little bit more in part one about that if you want to check it. And inside them, we declare some other controllers for the MQTT protocol, so interface communicate with the server, and servers gives most of the instructions to the boards. So the only instruction that it's not sent from the interface to the boards via the server, it's this top. And again, the only reason for that it's just for its speedness. Also, then you can be thinking, then why using the server and not directly managing and sending all the instruction if it is possible from the interface through the broker? Well, because we have to process a lot of things. We have to manage a lot of business logic. There's no direct application in the interface. We have to do a lot of processing, a lot of yeah, a lot of calculus, and we have a persistence of that. So that's the important part. And in the server, we manage all the processing, we managed all the heavy computation, and we also manage the persistency of the data, and that's how we connect to the database, right? I would like to take a look at your Canva presentation if you will be willing to share. Very clear explanation, thank you. Yeah, no worries. Actually, here in the repo, in all the repos, there is one that it's documents. Well, this is private. Okay, I will change it at the end, and I will upload, sorry, the PDF of the presentation there. Don't worry. Um, Also, here it's the part one. We break down this in the university I study um, in two parts. The first deliver, it's only in the planification, the theoretical aspects. And the second part, which is the one I'm presenting right now, it's when you already build it, right? So I will be uploading the documents to this repo, that's in the organization repositories, right? Yeah, but that will be at the end. Trust me, don't worry. You will have these slides. Okay, perfect. So let's return to this repository, which is the control one. This first device control in Lua. What do we have here? We have some deprecated files because we did a lot of tests uh, and there were some things I think they were worth saving, but not for the project, but for other reasons, right? So a motor controller and another version of the motor controller, an MQTT directly file. So again, this works fine if you just want to get MQTT working on the device, but we added another version of that. That's the MQTT controller. You will see why, but it's just implementation of this. I don't know, a set point and not miss one. That for a reason we didn't even call it a Lua file, but hey, things happen. So that's the deprecated one. The helpers. There's a connection Wi-Fi Lua. There's the control pi to validate what we were doing, and I paused this from Python to the Lua file. Minimum build, it's bin. This is the firmware. This is a binary file, so this is the firmware that we used for the minimal implementation of this. Then there's one that has 16 models that was built for specific reason of using this like in testing for trying to get what were the libraries that we needed. If that doesn't make sense, but trust me, I will explain that in a second. The secure build, it's like the minimal build, but it adds a secure model that was needed, which is the TLS or TTLS or something like that. And finally, the Node MCU Pi Flasher for 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 Mac. If you're not a Mac user, sorry I didn't include a flasher. You will need to find the flasher yourselves. But um, these helpers or this helper directory, it's the things you need to put this to work. Right now, the board already it's flashed with the binary file, which means it can support that I upload the Lua scripts in this using a tool called Node MCU tool. That it's another tool that you have to install in your terminal, or you can use no. I think there's no npx for that. Yeah, you should install in your terminal. You must. Um, what else? Some test. This test file was for testing one of these individually. Um, that's a huge thing in hardware that it needs to be tested and not only in your computer but in real life with measures and other things. Um, and let's explain a little bit more about this flashing before we continue to the actual Lua files. And for that, I think that the greatest thing we can do is open the documentation. Node MCU dot read the docs in English, and here's the link for that. And let me make this bigger, and let's start exploring. It's the first overview. Try to explain to you what the Node MCU development board is, what things you can do. You can do things like simple HTTP server running in this, for example, connect to Wi-Fi, make it an access point, manipulate hardware like Arduino, things like that. Also, I want to clarify that this is the hard way. I have to admit it. This is the hard way. You can do it through the Arduino IDE with some plugins they made for this board and not write Lua scripts, but the weird C++ that it has for Arduino. But I like hard things, I have to say it. And I thought that it was a great chance to get started in another language, which was Lua for me. I didn't know anything about Lua first. Uh, Now I know. Um, and I think it's like C, just but simpler, but really similar. But hey, um, and the other thing we need to understand is, for example, the basics get started has the building. You have to build the binary. This it's oftenly recommended doing it in a web service, which I used. And if you want to use my own implementation of it, there's in the helpers file, which is here. This is the binary, so you don't have to build it yourself. If you want to do it, go ahead, click here, go to the build. Here in the build, I recommend to you use the build on cloud, which is the link here. There is a cloud build service. This is the one I used. So you enter your email and you select the models you want, ABC, Bit, uh, Crypto, cron jobs, and Color One. Include the file. These ones that are selected. I strongly recommend not unselecting them. Uh, I go through that. I try to reduce as much as I can the models, and it failed. I have to admit it. But yeah, and there's some uh, models that requires other models, and I have to say that the builder does not warn you about this, so you have to be really aware of the models you want to include. um, but hey, don't worry. Just read the documentation. Everything's really really well documented. I will have to say that that's the benefit of it. um, for example, for mine, I remember I used the encoder one, I think, the MQTT, of course, the PWM for moving the motors with the H bridge. I used the SJSON. I used WebSocket. No, I think that's all. Actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think even less I used, but yeah. And of course, this is what the one I mentioned about the secure TLS or SSL. If you want to use secure connection, if you don't, don't worry, just not select this. You can donate and you can start your build. You can start your build without donate, but if you have the possibility, why not? Well, that's it. We can close that. So you already built the firmware. Now you need to flash that. For that, again, there are many options, but I already included the flasher. This is a DMG file. You don't have to install it directly on your applications. You just need to open the DGM file and then open the application, and that's it. Actually, that's an advice they give you even in the page, because how many times you'll be flashing and no MCU board? Probably if you select like a lot of useful um, libraries or models for your build, you won't be doing that in in a great time, right? So that's why they even recommend not installing that, just opening the application. And I know, Mac it's sometimes picky with the developers. Probably you will have to go to settings, secure settings, and allow the application to open. But that's it. No, no more complicated than that. And finally, when you already flash the firmware, the last part, it's just uploading the code. And for uploading the code, Actually, they have like the task and iOS selector chart that's great. For example, if I am on Mac, all the recommended build thing it's using the cloud. But hey, if you want to do it yourself in Docker, that's fine. In Linux, even you can do it natively. How? Well, you're a Linux user. You more know than me. More than me. Flash firmware. There's the MCU by Flasher. That's the file I'm sharing. Uh, Again, don't worry, I shared the macOS one, but here you can find the Windows. That's perfect. To upload the code, the recommended one they mentioned it's ESplore that it's on Java, but I love JavaScript, so I use NodeMCU too. That's the reason, and I have it in the terminal, and you will see where you're going to use it. Uh, we are not doing any LF task and things like that, so don't worry, don't put attention to this. But hey, we already have building, flashing, and uploading code. Perfect. So we now can continue to the code, to actually the code, right? There's this Node MCU tool configuration file, so I don't need to write anytime I use the tool, the baud rate I want to use, the port I want to use, and the connection delay I want to use. I strongly recommend using a connection delay. I faced a lot of issues that I cannot explain why uh, when I didn't add the connection delay. Um, yeah, it's a weird thing, but I recommend using the connection delay. So we have, for example, and I will try to tackle each one of these files individually. The main file, of course, as the name says, it's the main, um, well, the file that contains everything in the project. It requires the Wi-Fi controller, the MQTT controller, and a trajectory controller that we can call this the control controller, something like that. But a trajectory controller, just fine. Um, for the Wi-Fi, we set a network list. This one, for example, was for the internet I had where I was working on. Right now, I need to change it for the one I have right now, which is and the password. It's 01, I think. Um, I'm going to give the device ID here. So just for reasons, this is going to be Node MCU1. So for configuring the MQTT settings, the base, these are the topics. So the base topic, it's models. And again, how we know that? We declare that in the topic map. This topic map must be the same every time in the application. So the base it's models and the device ID slash it depends if we want the device status topic it will be connection. If we want the cleanup topic it will be cleanup. If we want the action topic it will be this is going to be a wildcard. So that means we are going to send this or subscribe for every topic that has a wildcard here, or send this to every topic that has all the values here, config and set point. And then we build this topic. For example, if we pass the set point as the base plus another slash plus the content that we want to add in the middle, config set point, working, it's the same, position is the same, and error it's the same, right? So we build an object for the MQTT settings, passing the broker host the port we want to use. Again, I probably we need to change this. Oh, here, here. Oh, oh my God! Stop changing it. Here, I changed it. I updated here to the IP I have currently in this network. The port it's the same. The client ID and the username are giving like it doesn't matter. The password it doesn't matter right now. The client ID is it's going to be the device ID. The this is another one that's the last wish topic. So if for any reason the device disconnects from the broker, this is going to be sent. The subscription topics. And as that, I set the device status as disconnected. The subscription topics that we want to subscribe to are the action topic and the cleanup topic with a QoS of 2, right? Then I create a variable for the motor that will be cleaned every time we make a movement and assign them again. This is for performance. I faced a lot of issues trying to get this work because I was running out of memory. One, two, three, four, five, six files of Lua having not that hard, but yeah, an interesting workload. Uh, Apparently, it's all that these boards can take. So I try to reduce the usage of the memory a lot. So let's continue. We create the controller instance for the Wi-Fi. So we just take the one we imported of the Wi-Fi controller file, and we set Wi-Fi controller new, and we pass the network configuration. Uh, Same as the MQTT controller new with the MQTT settings. We are going to see how this internally works. But for the moment, let's keep exploring the main file. So we define an optimized memory function that just performs the collect garbage, a cleanup motor. Then again, every time we use the motor, we clean the motor with the cleanup for the internal files they use. We set that as a nil to keep that values in the memory position, but cleaning them, so not using any other random space in memory, but having that already allocated, just erasing and writing the values every time. um, the MQTT controller it's going to publish that the motor received a cleanup, and the status for that it's going to be ready. Then we initialize the motor. There's another function, sorry, for initializing the motor. Um, we print the memory usage. If this is a protected call, so if this happens, if we initialize correctly the motor and we have that success, we return the nil. If this doesn't happen, we return an error, right? So this happens, and the main function begins with the connection to the Wi-Fi, right? The first thing we want to do is connect to the Wi-Fi. So once the Wi-Fi it's connected, and that starts at the end, Wi-Fi controller stands. Once that is connected, and that is happening here, the Wi-Fi controller or on the status connected, we are going to call the MQTT controller to start connection. And once the MQTT controller is connected, the first thing we do is publish the status of connection with a retain. Sorry, right now I explicitly put without, but because for a reason that was giving me misreadings on the other side. But hey, we could add a retain status. Then we clean up the motors just in case, and else nothing, no other thing happen, not automatically at least. The next thing is that we define an on message, same as for example the ones we already saw in the interface and in the server, right? And when we receive this message, we are going to handle that message this way. We are going to try to do a protected call again to decode the JSON of the payload. And if we have an okay, and sorry, if we do not have an okay, we are going to close that to prevent failures. But if we do have an okay, then we have a message. If the topic of that it's the cleanup topic, then we restart everything, we close that, we cleanup, right? If it is not a cleanup topic, then the only other one we were subscribed to, and remember we subscribe to that here, the cleanup and the action. If there's now the cleanup topic, we have an action topic. If the topic that comes from the function, the callback function, it's not a cleanup, then we are going to perform an action. And that action is going to give us to set up the motor and create a controller for that and publish some things. The first one is to publish the busy status. If you don't remember, in the part one, we mentioned that for managing all the telemetry, we did three things. The first one was set up the busy status that in servers starts a new instance of the tuning model. Then starts waiting for the telemetry. That's the function here, the publish position with the encode the data, the QS for telemetry. So in the server, once we receive the BUC, we open like the communication, then we start receiving all the telemetry data positions. Then at the end, we add another function that it's for setting the status not as busy, but as ready, right? Which is again in the cleanup. Every time that the cleanup is called, we receive that ready. That means for the server, stop this pile of telemetry, save that in an interface, and be prepared for the next one. That's it. That's great, isn't it? And another thing that's happening here, it's that we get the initialization of the motor and we set the instruction, that's the action for the motor to move to a specific position. Remember, the project is to move. Where is it? Here. Remember, the project is to move these big panels. Uh, these big panels with the motors here and following a trajectory described by this control law, right? So we should see a motion graph like this. Okay. Here is the treatment the tuning I was mentioning. We receive all this data from the devices. We store it in the database thanks to the server subscription to the MQTT topic. We close it and we have all this information from the device, right? The move to position, it's a method from the motor instance, and the motor instance comes from the init motor function, that the init motor function returns the trajectory controller. So this far we cover already what the Wi-Fi controller does, what the MQTT controller does, and the trajectory controller does. And the main file has the logic and manage the three of them. So let's go from the easiest to the more complicated one. The Wi-Fi controller, the only thing that does is that it sets the connection to Wi-Fi. So this file, it's just for that, to setting the connection to the Wi-Fi. How it does, we can discuss that later. You can take a look to the file, don't worry. But this controller is going to guarantee to you that you will be connected to Wi-Fi every time, right? MQTT controller, same as the ones in the server and in the interface. You receive a lot of things, but mainly you create the connection to the client, of course, using the um, model we included in the building. Um, so we have the M controller instance. Sorry, that one it starts init, and init uses the library MQT to create a new client. That client has the on message and the on offline that we saw every time in this project for the interface, for the server, and now we're seeing these on the devices, right? The only thing we didn't see before was this one that we already mentioned, that it's the last wish topic. So if for a reason this disconnects, it's going to say, hey, I disconnected. Why I do this? For the other subscribers, not to be looking for the information, but for receive the notification. Uh, Well, and it also contains the publish method that we already see in the other projects. So at this point, you already take what the MQTT protocol looks like and what you need to do. Create your client and start your subscriptions, and every time you want, publish your messages, and that's it, right? Oh well, and manage how you handle your messages in the subscriptions, right? Um, that's why it's very important to have consistency in your in your topics. Yeah, you define your topics, so it's up to you. Okay, and finally, let's go to the trajectory controller, aka or motor. So, trajectory controller has and also require another two, and I will say three models. The one for the PID controller, the one for the PWM controller, that's the one that's going to say to the edge bridge at what speed and direction this is going to be moving. The PID controller is going to actually do the control theory thing here. Um, Again, let's take a look at that really quick. So we compute, we take time change, we make and calculate the error, the set point difference between the input. We have an output sum, we have the derivative input, the hold output. Uh, well, the application of the law, right? What's in here in this PID, it's translated into this file, right? Um, for the PWM, it's just a controller for saying, okay, you're going to be moving forward or reverse in these boundaries of the PWM value into that direction. You're going to start and stop, and well, that's it. We define the hardware pins for that, but that simple, right? So returning to the trajectory, we set a lot of things. We set the motor control parameters, the rotary, and this is the third value I was mentioning. But thankfully and thanks God, I found a library that was already existing in um, Lua that was included in the binary file for managing the rotary. What a rotary is, it's a sensor that every time it spins, it tells you how many spins you have done and in what direction. So the resolution, the one I got, it's 2730. That means when this amount of clicks happen, that means the motor have performed one um, cycle, right? One loop. It went from 0 to 360, and that's it. Some trajectory parameters, some the execution time, is start time and stop time. This is for the trajectory of the Bezier curves and also the update interval. How many times we're going to be sending this to the telemetry in the broker. Again, I added this because if you do that frequently, you get a lot of information, but also the node MCU cannot handle that and it dies. We also have some running runtime states for the target set point, the current set point, if it is running, the timer, lapse times, some other the feed forward parameters, QB, QB, QA, the callbacks for the data completion, the completed callback, and the telemetry flag. So we initialize this, doing a lot of zeros, like setting everything to the start. Um, we can reset the rotary because sometimes I watch that the implementation of the code was no sorry of the model was not perfect. Sometimes if the rotary is like in an intermediate position, it starts receiving noise, so it needed to be restarted. And then we set the move to position, right? So we create the target set point, the data callbacks, the complete callbacks, and the begin time, it's the current time. We just pass it to milliseconds for because for a reason, and I do hated that the timer model sometimes it depends on the method you're using. It uses milliseconds, and in other times it uses seconds directly, and I was like, I hate this. But okay. Um, then we create the trajectory for the execution. We set them to the process trajectory. That process to the trajectory, it's moved to this. This is just again the control law we saw here. The other part, the PID one, was just this small block. This whole one, it's the feed forward plus the PID, and we do the closed loop, adding that to the error, right? Um, that order, it's here. We normalize the time. We apply the cubic interpolation, the interpolated set point. We calculate the feed forward, and then we have three phases again because these are curves, Bezier curves. We have an initial hold, then we start the movement, and then a final hold just to make sure the PID reaches the final point, the final set point. It should, in theory, just follow the trajectory, and that will be enough because the trajectory ends in the set point. But sometimes the life it's not as it should, and the trajectory ends a little higher or a little lower, and this period of time serves for it to reach it, right? To reach the point you wanted. So we update the parameters and we perform the control cycle. The control cycle, again, it's really similar. Yeah, sorry, I mentioned timer in milliseconds. In other times, they are in microseconds, not in seconds completely. And I find that really annoying. But hey, no worry. Um, so yeah, this same, it's the control law being applied. Then we stop that, and that's it. So these one, two, three, four, five, six, seven files, which we already talked and discussed and explored, are the ones that are running in the microcontroller, right? In the Node MCU. And finally, I created a bash file to upload everything directly using Chalk. No, not Chalk. Sorry, I was thinking in JavaScript. Um, just showing that we need to upload a lot of information here, but instead of doing that manually, that's why we have Bashful, right? Um, so let's connect this to the computer to upload that. Um, and I will show you how to upload the code, and you will see how this device connect to the broker, because of course we are going to see the broker giving us the connection steps, right? I already plug this in, and let me open my terminal. I'm going to do node MCU tool device to detect the devices. I have this, so I'm going to copy this and make sure that's the one I have in my notes tool. Okay, I had another one because probably I was using it for another device. Devices again. Okay, seems fine. Now node MCU. Just to make sure that this is working, I have an FS info. Okay, see, enable to establish connection. Sometimes that happen. Um, I'm going to do that again. Okay, and now it tells us that this was already holding some of these files. Why, Alberto? This is a main and not in, sorry, in this is an ILC extension and not a Lua. These are Lua compiled, right? I compile them to try to reduce as much as I can the size and the usage memory. So these were compiled. What's the difference between uploading them directly and compile? Just the memory usage. Don't worry. Um, so let's run the script to upload all of our files. So we are going to see that Node MCU scripts load, restarting first the Node MCU. Then we are going to format that to make sure that it's clean. And when you format it, it doesn't mean you erase the binary file, the firmware. You just erase the files included. So if I format it and run this file info again, we will see there is no files in it, but it still has the firmware, right? I hope that makes sense. So it's formatted successfully, and now we are starting to upload the files. We are going to upload Lua, and for that, we will see here how we execute that upload. We upload that echo file node MCU here. Node MCU upload. We not only compile it, but we minify it. So I tried to save a lot of space there. So we start uploading the PID controller, the PM controller, trajectory controller, everything, right? And finally, I ask myself if I want to upload the init file. And the init, it's one file we haven't covered. So I'm going to say no. Um, the init file, the only thing that does, it's that when this init file is present on the file system of the Node MCU, it's going to be executed automatically every time the board is powered. Right now, the board it's not running anything. Actually, I can say like node MCU tool FS info just to verify that everything was correctly uploaded. Okay, everything seems fine except for the main. I don't see a main file here. That's weird, but I'm going to node MCU tool upload main minified and compiled, right? Then node MCU reset and node MCU FS. Okay, perfect. I see now the main file. I want just to make sure. If I access, because now the board again, it's connected to my computer. If I access the terminal, I will see there's nothing happening there. Um, Here I can type do file main.lc, and I will see this should be running the main file, but I don't see any output of it. Okay, well, the point was node MCU tool reset and node MCU tool upload the init file. Now, since we now are adding the init file and we reset and we add the terminal, access the terminal, we will see that the board it's running was in the main file. We should see the print base starting, but I don't see it. So I'm worrying that something's not right. Okay, yeah. We print that base running the main file without I doing anything or explicitly telling this to run. And that is because, oh, probably I need to change the configuration. Hey, I'm sorry, I have to apologize. I'm done when I click the disconnect from Wi Fi. So let's resume where we leave it here. And I was mentioning that here the connection network says that it failed. So I'll try to connect again. Um, so there's the copy password here. Okay, should be that. And just to make sure, let's see, the connect does the okay, okay, should be that. Um, I'm going to close that node. MCU. Sorry, I'm going to load all files again just to make sure. Again, it's going to be erasing the file system, cleaning that, and trying to publish again. We can close this. We already covered what the init file is, so fine. And the node MC2 file as well. And this time we're going to say, yes, we do want the init file. Yes. Okay, and let's see the output to see if everything was uploaded as it should. I don't know why it's not loading the main one, but hey, node MC in the MC tool, remove first the init just to prevent everything. Node MC tool reset. Node MC tool upload the main one. Node MCU tool file system just to make sure everything is fine. Now we have the main. Now Node MCU tool upload the init one, and finally Node MCU tool reset Node MCU tool terminal just to see the output. Now it's running the main file, and the main file should connect us to internet. Um, let's see. Okay. Um, I I realize I removed the print statement. So let's explore the MQTT dashboard, and also let's explore here in the console of the terminal. We have the telemetry for Node MCU1, which is the board where we connected, saying that the status is ready. Let's explore on the clients, and if we refresh it, let's see that we have the Node MCU client ID 1 as connected. And finally, we will see that in the interface that we were checking, we can now interact with motor 1 and motor 2, since motor 1 and motor 2 are the ones that are in charge of the board 1 of the Node MCU 1. So if we set a set point of 120 and we add the telemetry, we can see here, and you will see these devices start to bleep here right now because it's sending that information. And of course, now um, we can go to the control graphics, and we will see that in motor 1, we receive this information from the device, which is we try to move this trajectory. This path was generated inside the node MCU, and it was output to our broker and then received it in the server and then stored in our database and then accessed via the server in the interface. Of course, it didn't move. This blue line, it's because we're measuring nothing. This is not connected to anything. And the output told us that in the PWM pin here, we received this signal. So this device read nothing, output a huge PWM value almost all the time, but it was gradually increased, and calculated a perfect trajectory. So that with the appropriate connections, meaning this, connected to the motors through an H bridge with the two um, power devices, one of 5 volts and one of 12 for these specific motors, can move the project to do something like this. And we played this video on the part one, but I think it's worth playing that in the part two because you can now easily relate to what we were talking if you didn't watch part one. So, with this, we finish. Remember, the scope of the project was uh, making the acoustic treatment of an audio room. We generate some audio files, we make some predictions, but at the end, it translated in the movement of these panels. So we generate the prediction of what they need to take. We do that in the first stage with the odd panels and then with the even panels. So now they move that. It was not yeah, you saw that it was not a complete move with the same values. It started low. It had a high movement at the middle, and then it started decelerating also low, um, like an ease movement, right? And that's it. So I will have to say thank you. Remember the repo containing everything. It's well, not only a repo, but the repos of the organization containing everything. It's available here. I will share the link again because I missed it here in the comments since I entered back again. And well, if you have any question, I'll be around trying to answer to you here while I download the PDF of the slides and upload it to the documents repository and make it public. And that will be the end. Thank you so much for being here. Thank you so much for listening to me. And with that, we end. Of course, the video is not going to be available in the slides, but I can share. Okay, but yeah, but I can share the rest. Okay, okay, I have them now. Um, Perfect. So here I just need to make them public. Settings. Oh my god, two-factor authentication can be sometimes a pain. Okay, GitHub Mobile, I have you now. Hey, I didn't receive anything. Send it again. Okay, any questions? Okay, it was changed now. This is public now. And finally, I just need to add a file. Add the file I want. I'll be uploading the not only the slides but also the report we generated. I think that would be great. What other file? Well, okay. Um, Ready. That's the slides for you to check it out. And well, again, thank you so much for joining me. And well, be tuned because this is ending. You will have the closing ceremony tomorrow with Cecilia and Queen. So stay tuned with that. It was great to have you here. Thanks and happy hacking. I hope to see you in the Global Hack Beginners Week really, really soon, right? So, bye.